Dear students, today we are going to study the topic electron beam lithography, in which which comes under the RTU quota syllabus, Electronics and Communication Engineering, 8th semester. Subject name is MEMS and Nanotechnology, in which chapter 2, that is Nanofabrication and Patterning Technique. So let's begin with the topic electron beam lithography. This student electron beam lithography is the fabrication technique that allows us to create pattern at a nanoscale level. Electron beam lithography devices are similar to electron microscopes or scanning electron microscopes. Electron beam lithography, it is the one most powerful method for forming pattern at nanoscale. It uses a high energy electron beam to etch desired geometries on a light sensitive film. In this technique, a beam of electron is utilized to generate patterns on a substrate surface and creates a very small structure such as ICs or other nanostructure devices. Electron beam lithography can produce small features as small as 20 nanometer. It uses high voltage electrons in the range of 1 kilovolt to 100 kilovolt to nano pattern the deposited resist on the substrate by directly writing onto it. A very high resolution of several nanometer can be obtained with this method. So student, this electron beam lithography technique is flexible, and one of the advantage of this technology is it does not require expensive mask. So this is the basic introduction of electron beam lithography. Despite the high resolution and ease of application, the commercial value of electron beam lithography is still limited because of its speed. So this is the time consuming process. The beam exposes the pattern must be scanned across the surface as line by line or dot by dot. This makes for the very slow pattern generation compared with other techniques such as photolithography. In photolithography, the entire surface is patterned at once. This technique does not require a pre-existing mask, therefore the patterns are created and transmitted electronically. This technique is ideal for low volume applications where only few copies of a pattern are required. Therefore, it provides a great flexibility to produce different pattern in a very short time duration. So now let's start with the basic working of electron beam lithography. This electron beam, in a very short, this electron beam lithography consisting of scanning a beam of electrons across a surface covered with a resist film sensitive to electrons. Therefore, it depositing energy in the desired pattern on the resist film. Electron beam lithography basically consists of irradiating a surface covered by polymer, that is resin, using a focused beam of electrons. Here the PMMA, this is the polymer, the absorption of energy in specific places causes intramolecular phenomena such as the breaking of the molecular bonds defining the characteristics of polymer resin. Under the influence of the electron beam, the resin is divided into small molecular unit using an appropriate development solution. The fractured polymer chains are selectively dissolved. Non-exposed areas remain insoluble in the revealing solution. Consequently, a mask is formed on the substrate, a metallic deposit on that substrate followed by the lift of unwanted parts gives us plots whose form is different determined by the pattern. So here this is the symmetric diagram of the electron beam lithography. Here, in which this is the PMA, this is called polymer. This PMA here, the this substrate material covered by PMMA using a focused electron beam. Now, under the influence of electron beam, the resin is divided into small units. Now, the polymer chain is dissolved by using appropriate solution. Here, non-exposed area remains insoluble. So, now the mask is formed on the substrate. These are the advantages and disadvantages of electron beam lithography. Here are these are the advantages. It allowing multiple designs to be fabricated together on one wafer. It is flexible and it is maskless, so there is no expensive masks needed. The basic disadvantage of this technology is its slow speed, it is time consuming, and it is expensive process. Applications of EBL are cryo-electric devices, optoelectronic devices, quantum structures, transport mechanism studies of semiconductor and superconductor interference. In microsystem techniques, it is also uses optical devices, etc. Thank you for watching.